Hi everyone, today we are going to continue with our previous video wherein we were studying the logical design of IoT. In our previous video we have covered the IoT functional blocks, and in today's video we are going to study the IoT communication models. So what are the IoT communication models? Basically, the IoT communication models are tell you about the different types of models that are available for communication in an IoT system. The four different types of models that are available in IoT for communication are the request response model, the publish subscribe model, push pull model, and exclusive pair model. So these are the four main models. There are other models also, but the four major models that are available for communication in any IoT system are these four models. So we'll start with the first one first, that is the request response communication model. This model is a communication model in which a client sends the request for data to the server and the server responds according to the request. So as I said that this is a request response model. So in this request response model, the client sends the request for the data and the server responds to that request. When a server receives a request, it fetches the data, retrieves the resources and prepares the response and then sends the data back to the client. So whenever the server receives the request from the client side, it will fetch for the data from its repository or database, prepare the response, and once the response is ready, it will send the data back to the client. Now you know in internet all the data is stored in a database which is a server, right? So every time the client wants access to a particular data, it will request the server for that data. So you can see there is a client and server in this model, and this is a resource. Resources are basically in the repository or database of the data. So the client sends request to the server, a request is sent to the server. Now the server receives this request from the clients, processes this request, looks up or fetches for the resources in the database or repository. Once it has found that particular resource or data, it prepares the response, and once the response has been processed and prepared, it sends the response back to the client. So this is how the request response communication model works. The best example of your request response communication model is the web browsers on which you work. So the web browsers are basically the client side, and when on your web browser you type the name of any website, that request from there goes to the web server. If the web server has that particular website or data, it looks up for it in its repository. If it is there, it fetches from there, then it prepares the response and then sends the response back to the client, which is the web browser. So when you see the home page of any website on your computer screen, you know that the server has sent the response back to you. So the moment you type the name of a website, it is a request from the client side, which is your web browser. The moment you get that website's home page on your computer screen, that means the server has processed and sent your response. So this is the example of a client server or request response communication model. Now in this particular model, HTTP is the protocol which is used as the request response protocol. That is why you must have seen that even if you do not type HTTP in the URL of your web browser, say you just typed www.abcd.com, but even in that case, by default HTTP will come here. Why? Because HTTP is that particular protocol, the hypertext transfer protocol, which is facilitating the request and response procedure in a request response communication model. Example, as I already told you, when we search a query on a web browser, then the browser submits an HTTP request to the server, and the server returns a response to the browser, which is your client. So now from next time, whenever you sit on your web browser, you know that is the client side. When you type the name of the website that you want to see, you know that is a request or a HTTP request being sent to the server. And when you get to see the home page of the website that you had requested on your screen, you know that the server has responded to the client's query. Now the another kind of communication model is the publish subscribe communication model. In this communication model, there is a broker between a publisher and the consumer. So basically, before I proceed with the publish subscribe communication model, you saw that in the request response communication model, at any given point of time, one request and one response was being entertained. But at times when there are multiple requests from multiple sources, so how can we cater to such requests? That is with the help of publish subscribe communication models. So this is one such architecture which responds to several requests at the same time and asynchronous communication form. In this communication model, there is a broker between publisher and the consumer. So basically there are two main entities. One is the publisher and another is the consumer. That is why the name publish subscribe communication model. Here publishers are the source of data. That means the data is being provided by the publishers, but they are not aware of the consumers. So the publishers themselves do not know who all their consumers are, and the publishers are the source of data. That is from where the data is originating. Now the publishers send the data which is managed by the brokers. So the brokers are the middle party, are the middlemen. So these brokers manage the data which is being published or sent by the publishers, and when a consumer subscribes to a topic of that publisher, the consumer subscribes to that publisher, and even in the subscription it can subscribe to particular topics of that publisher. So when a consumer subscribes to a topic, that is managed by the broker. All this is being managed by the broker. And when broker receives, since broker is the middleman, so when broker receives the request of that particular data, when the broker receives data from the publisher will keep on publishing data, right? So there is no request response model over here. These consumers are not requesting for any particular kind of data. They are just subscribing to the topics, and whenever a publisher publishes a particular kind of data relevant to a particular topic, the broker receives data from the publisher, and then as per the topic subscribed by the consumer, the broker sends the data to all the subscribed consumers. So if we look at, so broker, as I told you, normally performs a store and forward function. Now in a layman's language, we say that broker is the middleman who is managing all the data between the publisher and the consumer. But in the in computer language, your broker basically performs the store and forward function. That is, it stores the data as and when it comes, and then it forwards it to the subscribers as per the topics that they have subscribed. So it is a store and forward function which is performing the routing of messages or data from who? From the publishers to the subscribers, obviously. So one publisher can have more than one subscriber. So here you can see an example. There is a publisher sends messages to topics. There are several topics, and as per the topics, this publisher would send messages relevant to those topics. Now there is one topic, there is another topic. Say for example, one topic is home decor and another topic is technology, to make you understand better. Topic A and topic B is less understandable, but when I say one topic is home decor and another topic is technology, now this particular publisher has sent messages as per the topic. If it publishes something related to home decor, it will go to topic A. If it publishes something relevant to technology, it will go to topic B. Now as per the interest of the subscriber who has either subscribed to home decor or technology, or may have subscribed to both, he will receive the messages as per the topic he has subscribed. So if, say for example, subscriber 1 has subscribed to both the topics of home decor and technology, so whenever the messages are published in these two categories, he'll receive those messages. Then subscriber 2 also has subscriber 1, as you can see, has subscribed only to home decor topic. So whenever something in home decor is published, subscriber 1 will receive the messages. Subscriber 2 has subscribed to both topic A and topic B. So whenever something is published either in the home decor topic or in technology or in both, he will receive messages from these topics. And subscriber 3, as you can see, has subscribed only to technology. So whenever something is published in the technology topic, he will receive messages for this particular topic. So this is how the publish and subscribe model works. As an example, you can see that on many websites, many times we subscribe to their newsletters. When we subscribe to the newsletters of various websites using our email address, these email addresses are managed by some third-party services which we call the brokers. And when a new article is published in a website, it is directly sent to the broker, and from there the broker sends these new data or posts to all the subscribers as per the topic that they have subscribed. So basically in a publish and subscribe communication model, there is a publisher who posts the data. There is a subscriber who follows or subscribes to that publisher. There are topics relevant, there are topics which classify the category of the data. Then there is a message broker that that forwards the messages from the publisher, and then there are messages which are the actual data that has to be consumed by the consumer. Another real life example of a publish and subscribe model is Twitter. See here, the publisher is the are the user post. What is the publisher here? Publisher is the user post user posts or user tweets which are published to the Twitter platform. That is the publisher. Then who are the subscribers? All the followers of a user are the subscribers of that particular publisher, right? So you subscribe to a particular celebrity or a particular person on Twitter so that you can receive their tweets. So you are the subscriber in that case, and that particular person who tweets is the publisher. Then there are topics. Each user tweets can be considered as a topic, and subscribers receive updates for the topics that they are interested in. Then there is message broker, or the broker as we call it. Twitter's backend infrastructure acts as a broker or the message broker, which because it is routing tweets from the publishers to the subscribers. And then there are the tweets, which is the actual message. Each tweet is a message published by the user and received by their followers. So Twitter is also a real life example of the publish and subscribe model. Then the third kind of communication model is the push-pull communication model. In a push-pull communication model, the data is pushed by the producer in a queue and the consumers pull the data from the queue. So there is a producer and there is a consumer. The producer produces the data and pushes it in a queue. The consumer pulls that data from the queue. So here also, just like in the publish and subscribe model, the publishers are not aware of the consumers. Here also the producers are not aware of the consumers. They just keep on producing and pushing the data into the queue. Now queue, when I say queue, that is actually a buffer. Queue acts as a buffer which helps in situations where there is a mismatch between rate at which producers push data and consumers pull data. It is not necessary that at all times the rate at which producers are producing data, the consumers will consume the data. So if there is a mismatch, in that case data can be temporarily stored somewhere, which is a buffer, and this buffer is known as a queue over here. So basically this is how the model is. Through diagram we can see there is a publisher who is sending messages to the queue. This queue is basically a buffer. The messages are pushed to these queues or buffers. Now there are multiple consumers of the same publisher, consumer 1, consumer 2, like this. So the messages are pulled from queues by these consumers. Example is that when we visit a website, we see a number of posts that are published in a queue. In a website you can see number of posts, like posts. So according to our requirements, we click on a post and start reading it. Say for example, in a college, if you go to a college website, there are multiple posts. There are posts related to vacancies, there are posts related to the new events in the college, the posts related to when the semester exams are happening. So you click on a particular link or a particular post as per your interest. So you are the consumer and those posts are the messages that are published by the publisher. Now the fourth communication model is the exclusive pair communication model. The exclusive pair communication model is a bidirectional fully duplex communication model. When I say bidirectional, that itself means fully duplex. A communication model that uses a persistent connection between the client and a server. So here there is a client and a server, and it is a fully duplex communication model. Now the connection that is used between the client and the server is a persistent connection connection. That is, first you set up a connection between the client and server, and this connection remains open until the client sends a closed connection request to the server. So that means basically you're having a dedicated connection for that particular client and server. So here you can see that is why the name exclusive pair, because that means this connection is exclusively for this particular client and server. So how this model works is that, first of all, the client sends a request to set up a connection, because the client is the one who wants to request data. So first of all, the client will require to set up a connection with the server. So in order to set up a connection, the client will first send the request to set up the connection. Now after the server receives the request to set up a connection, it will give a response accepting the request. It will say okay. If it accepts the request, it will send a response that I have accepted the request. Once the client knows that the server has accepted its request to set up the connection, the client will send a message to the server. So in the third step, message goes from the client to the server, and in the fourth step, message goes from the server to the client. The message from the client is usually the request for a particular data, and the message from the server is the response to that particular request. Now once the client has received the response to its request, and it is no longer requiring any more data from the server, then the connection closed request would be sent by the client to the server. Here a connection closed request is sent because this is a dedicated connection. So unless this client releases this connection, the other client will not be able to use this connection. So there is no point unnecessarily keeping the connection when the client no longer needs any data from the server. So when it is done, the client will send a connection closed request to the server, and the server will respond to this connection closed request, and after this the connection will be released between these two clients and server, and this connection then can be used by any other client server pair. So hence this name is exclusive pair communication model. So this was all in the IoT communication models. Now by now we have covered the IoT functional blocks, IoT communication models. In the next video we are going to cover the IoT communication APIs for the logical design of the Internet of Things.